You're limping through a cramped spacecraft, ankles swollen like it's auditioning for a grapefruit commercial, and the nearest hospital is 33 million miles away on Earth. By the time a message to your doctor gets a reply, you'll either be healed or part of Martian history. NASA and Google's new AI doctor, Simi, changes that diagnosing and guiding treatment instantly. It's August 2025, and this isn't sci-fi. It's one of the ways AI is becoming humanity's secret weapon for exploring the Red Planet, helping astronauts survive, thrive, and maybe even snap a few AI-approved selfies. Let's dive in. AI Doctor on Call. Meet CMO. The Crew Medical Officer Digital Assistant, or CMODA, is more than just an algorithm, it's a lifeline. Powered by Google Cloud's Vertex AI, it can process voice, text, and even images to evaluate a medical situation and suggest treatments on the spot. In simulations, it achieved diagnostic accuracy rates that would make some urgent care clinics jealous: 88% for ankle injuries, 80% for ear pain, and 74% for flank pain. These aren't toy tests. They were assessed using the rigorous OSCE framework that medical schools rely on. This means astronauts can have a doctor who never sleeps, never gets cranky, and won't judge you for coming in with something embarrassing. More importantly, it closes a dangerous gap in deep space medicine, where delayed communication can turn a manageable injury into a mission-ending emergency. And the beauty of CMODA's design is that it's not just for space. It could one day bring advanced diagnostics to rural communities here on Earth, proving that Mars technology can also heal earthly problems. A rover with brains. If astronauts have their AI doctor, rovers have their AI scientist. Enter PIXL, the Planetary Instrument for X-ray Lithochemistry, a mouthful of a name for a small but powerful device attached to the Perseverance Rover. PIXL doesn't just analyze rocks, it decides which ones deserve a closer look. Using adaptive sampling, it scans a surface and determines in real time which microscopic spots might hold clues about Mars' past. In other words, it's a robotic geologist with the instincts of Indiana Jones minus the fedora. This autonomy means scientists on Earth don't have to micromanage every move, saving time and precious rover energy. Instead of wasting hours on unremarkable rocks, PIXL focuses on the A-list specimens, mapping their chemical composition at a resolution finer than a human hair. This is more than convenience, it's the difference between stumbling across history and walking right past it. Autonomy in action. Perseverance is not just smarter because of PIXL. The rover also benefits from an onboard planner that helps it schedule its own tasks, deciding whether to keep exploring, stop to recharge, or investigate a sudden dust swirl. This kind of autonomy is a game changer because sending commands to Mars and getting a response can take anywhere from 4 to 24 minutes. Imagine playing a video game where every button press has a half-hour lag. It's no way to operate a billion-dollar robot. AI solves this by letting the rover make decisions in the moment, much like a self-driving car that decides when to brake without calling its manufacturer first. And this is just one example. NASA's AI toolbox also includes systems like Aegis for targeting science instruments automatically, AutoNav for navigating tricky terrain, and MLNav for training rovers to drive more efficiently based on past experience. Together, these tools are turning Mars rovers from obedient order takers into proactive explorers. Mission planning gets a brain upgrade. While rovers roam the surface, a whole other layer of AI is working behind the scenes to orchestrate every move. NASA's Planning and Scheduling Group uses systems like ASPEN, CLASP, and AWARE to juggle thousands of variables: power levels, communication windows, data bandwidth, and scientific priorities. It's like air traffic control, but for a planet where the air is mostly carbon dioxide and the traffic is robots and orbiters. These AI systems can reschedule activities on the fly, optimize resource use, and even reassign priorities if something unexpected happens like a dust storm or a sudden equipment glitch. Without this, Mars missions would be slow, inefficient, and far more expensive. With it, every solar Martian day is packed with maximum productivity, and that means more science for every dollar spent. In many ways, it's the invisible conductor ensuring the orchestra of Mars exploration plays in perfect harmony. And just like a great conductor, its presence is only noticed when something goes wrong. Otherwise, It simply makes the impossible look effortless. Learning from Earth before we leave it. Before any of this AI makes it to Mars, it gets tested here on Earth in simulated missions. One of the most ambitious of these is CHAPEA, the Crew Health and Performance Exploration Analog. This 3D printed habitat at NASA's Johnson Space Center in Houston is designed to mimic the conditions of living on Mars, complete with delayed communications, limited supplies, and plenty of psychological stress. The first CHAPEA mission wrapped up in July 2024, with a crew spending nearly a year inside. The second mission is set for spring 2025, and it will further test not just the astronauts, but also the AI systems that will support them. This kind of testing is crucial because once we're on Mars, there's no going home early if something doesn't work. By rehearsing every scenario on Earth, NASA is making sure its AI is as reliable as its rockets, as resilient as its astronauts, and ready to handle the curveballs Mars will inevitably throw. In a sense, CHAPEA is Mars dress rehearsal, only the stage is a lot safer and the snacks are way better. Why this isn't just about Mars? It's tempting to see all of this as space-specific, but the truth is, the benefits are far more universal. AI doctors like CMOD could revolutionize healthcare in remote regions, bringing advanced diagnostics to communities without local medical specialists. Autonomous navigation and adaptive sampling could improve Earth-based robotics in mining, agriculture, and disaster response. Even NASA's mission planning software could find uses in industries like shipping and logistics. In other words, every step we take toward Mars is also a step toward making life better back home. And yes, that means your future Amazon delivery route might be optimized by the same algorithms that plan a rover's path across Jezero Crater. The innovations forged for the harsh realities of space have a way of trickling down into everyday life, quietly reshaping industries and expectations. In time, you might be benefiting from Mars tech without ever realizing you've had a little piece of the red planet working for you. The human element behind the AI. Behind every AI breakthrough is a team of humans who make it possible. Engineers like Vandy Varma, who has worked on multiple Mars rovers and helped develop the PIXL software used for planning and execution, are the bridge between human creativity and machine precision. These people understand both the technical demands of space exploration and the unpredictable nature of human missions. They're not building AI to replace astronauts or mission control, they're building it to make them more effective. It's a partnership, and like all good partnerships, it thrives on trust, communication, and the occasional, wow, that actually worked. Their expertise ensures that AI complements human intuition rather than overrides it, creating a balance where both can excel. In the end, it's the collaboration between brilliant minds and brilliant machines that will carry us farther than either could alone. AI as a co-pilot, not just a tool. As of August 2025, the role of AI in space exploration is only getting bigger. NASA's next-generation missions will lean even more on autonomous systems to handle the routine, the risky, and the unexpected. This isn't about handing over control to machines, it's about giving humans the tools they need to push farther into the unknown. When the first astronauts set foot on Mars, they'll be doing it with AI by their side, helping them make decisions, stay healthy, and achieve more than was ever possible before. And maybe, just maybe, those astronauts will have a moment to look back at Earth, smile, and think, we really couldn't have done this without the robots. AI on Mars isn't science fiction anymore, it's our partner in pushing the edge of exploration. From diagnosing injuries in deep space to picking the most promising Martian rocks, it's fueling our spirit of adventure and giving us the tools to survive it. The red planet is calling, and AI is making sure we can answer. Thanks for watching. If you enjoyed this journey, hit like, subscribe, and let me know in the comments what's the first question you'd ask an AI on Mars?